Hello and welcome everybody. Good morning, good evening, good afternoon, depending on where you are. And welcome to this first of a couple of workshops we are running before Nodes, which is happening on the 26th of October. And this is the first edition, Road to Nodes, Intro to Neo4j, and interactive dashboarding with NeoDash. So I'm super happy, super excited about the session. I see people joining from all over. Obviously, I'm based in Munich. We have a couple of people here from Rochester, from Seattle, from India. So nice to see you all. Use chat as much as you can. This is really an interactive session, so type away if you see something cool, if you see something interesting, if you want to know something, if you have a question, please use the Q&A panel if you can, so that way it's a little bit easier for us to sort out questions and comments and to get answers to you out as quickly as possible. We'll try to answer many questions during the session. If all your answer or all your questions cannot be answered, then it's obviously not because your question was too difficult or too stupid. It was just as we didn't have time enough to come to it. So sorry for that in advance. But there's also always the community that is ready for your questions. So you either on Discord or on our community forums, and take your questions there, and then you should be have another chance of getting some answers. The session will be recorded, so yes, you can watch the video afterwards if you miss something, if you are want to rewatch something, if something was too quick. And the slides that we'll be presenting during today's training will also be shared with you afterwards if you registered officially via the Road to Nodes event. So that is more or less all I had in terms of housekeeping. Who will be with us today? So we have my lovely colleagues Andreas and Niels, which I'll be enabling right now. So here they are. Andreas is from the DevRel team, famously known around the community for a couple of presentations and talks in the past. And Niels is in our field organization. And he's famous for developing and coming up with the great idea of a tool called NeoDash, which we will learn about a little bit more later on today. So yeah, hello Andreas, hello Niels. How are you doing today?
Hello Alex, good to see you today.
All good.
Good to see you too.
I'm good.
Great. And in the back end, last but not least, not to forget about him, is Martin, who will be helping out with, especially with Q&A. So he's around in chat, he's around in the Q&A segment. So he'll be helping out with all these questions that you might come up with. Yeah, and with that, I think we're ready to go. I'm looking forward to this one. If there's time in between sessions or in towards the end, I will come back again and read a couple of questions out loud, so we can maybe take a couple on during the live. But yeah, I think that's it. And first up is Andreas, I think. So I'll slot you in here, and I get rid of the rolling banners here. And
looks fantastic.
Looks good. All right.
Good. Thank you, Alex, and hello, everybody. I'm going to do a bit of context setting for us here. And for those of you who are new to Neo4j, or maybe you haven't used it in a little while, it'll be just a quick reintroduction to Neo4j as a database, what the data model looks like inside of the database, and what Cipher, our query language, looks like. So a very quick introduction from me. And then you get to do the really fun stuff with Niels later on. So bear with me for a little bit as we do a quick review, a quick introduction to Neo4j. Okay, so the things we're going to cover today, I'm going to do a quick intro into what is a graph database and how to query a graph database. And then it's on to NeoDash, and you'll get to see, I think, some live demos as well, which I'm looking forward to. It's a fantastic new tool. So let's get right into what is a graph database. Okay, the graph database fundamentals. And for us at Neo4j, we deal with data. We're a database, of course, right? So we have a data graph that we store inside of the database. So the data that we talk about, what usually you would call just records for us, because it's inside of a graph, we call each of those records nodes. So here, classically, you draw a node with a circle, and then maybe you give it some kind of a information inside of that circle to let you know what's there. So here, this node is a MacBook. Nodes typically inside of a database represent the things in your data set. So like here, this is a MacBook, it's a laptop, it's a computer, and it's in some sort of a category, of course. So all of the things you want to represent end up becoming nodes inside of the graph. And for each of those things, you can then have groups of them set together. And the way that you group nodes together, so if this is in a kind of retail setting and we're selling products, this particular MacBook is one of those products, so we'll add it to the product category by giving it a label. Now, labels are interesting because you're not restricted to just having one. So here I've said that this is a product, so we know that it's in that group of things, which is nice. And if we want to, we can add additional labels. And as an example of that, we think that perhaps MacBooks are a little bit fragile. I have one here. If I happen to tip it off this table, it is certainly fragile enough that I don't know how well it'll survive a crash to the floor. So fragile seems like a reasonable label to add to this as well. And fragile is interesting because you could think of that as a subset of things within products, but there's things that are not products that are also fragile. So depending on what's in your data set, the way that you use the labels can either have subsets of things or they can have groupings of things that cross over other groupings. Both patterns are completely legitimate. Now that we have this item, that we have this product inside of our database, of course, to make it a data record, we then want to add some fields to it. In Neo4j, we talk about those fields as being properties. Properties are just key value pairs. So the details of this MacBook are that the name is it's a MacBook Pro. It has a price attached to it as well. It's a bit pricey, but I think it's worth every penny or every cent or every euro, perhaps, that it's being sold for. And that's the way that we start. But of course, we have multiple groups of things inside of any kind of a data set. Here, in addition to that product, that MacBook, we might also have a customer that you care about. So if you're in a retail setting, this is the classic place that you start, right? First, what are all the things I have to sell? Then as you get customers, you want to know something about those customers also. So I've added a new node here as a customer, and we know the details of this particular customer is Andreas, and he's got an email address as well that he's kindly given to us at one point. So we keep track of that inside of the database. This already is a perfectly legitimate graph. Graphs have at least inside of them the things that you want to talk about inside of your domain. So that's the basics of where we start. But then to make it, properly graphy, it's not just that we have things, we know that there's connections between these things. So this is the very next step. In addition to having the nodes as the fundamental data records inside of the database, we then have relationships that connect those nodes, connect the data records. So this extra blue line here indicates the relationship that we have inside of the data. And that relationship that we create is always between just two nodes. So it's between the customer and the product in this particular example. And it always has a few extra features. Not only does it have direction, it's going from that customer over to the product, it always has a type. And the type of this particular relationship is that this customer, me, I gave a rating to this product. You could tell when I started talking about this, it's like, I like MacBooks. So of course I gave a rating. Even just giving a rating at all is an indication that I have some positive or some strong enough feeling on this product that I wanted to contribute a rating towards it. So it's worth keeping track of that as an actual piece of the data inside of the data set. Now, similar to having nodes that have details, the extra details of the relationship is that they always have a direction. Here, the direction is from the customer to the product. And it's more than just that. They can also have properties attached to them as well. So it's great that I've rated this product, but we want to know what was my rating. So that goes into the relationship. And you can also know when I created this relationship. So I created this rating on the 03/22/2023, depending on your system of days. I'm not sure which one that indicates. I guess that's probably year, month, day in that particular setting. So that's the basics of it, right? That's what our data model looks like as an example. This is how we start structuring all data within Neo4j. Whatever your domain is, these are the fundamentals of doing that. So now that we have some data inside of the database, we then have some kind of way of, we want to be able to query this data so we can get it back out, so we can actually look for things inside of the data set. And the query language that we use for that, we call Cipher. Cipher is a declarative query language, and it's fundamentally based on pattern matching. So let's go through a little bit about what that means, and we'll get to the rest of this as well. This was the model that we were just showing, taking me out of it and taking the particular product that we were looking at out of it for the moment. So here it's just customers that rated a product. How would we describe that using Cipher? Because it starts with pattern matching, we want some kind of a text way of actually describing what the pattern is. So what we end up doing is we have what we call this ASCII art style syntax. And if what you want to do is first describe the nodes, the way we first created the nodes inside of the data set. If you're just typing on your keyboard and you look for something that looks like a node, this nice circle, of course you use parentheses, right? Parentheses around the node, and that's the place to start. So now we have a set of parentheses on one side, set on the other side for customer and for the product. That's pretty great. The next step then, of course, is say, okay, we know that we had labels on both of those nodes. The way that we put in the labels, we have a colon and then what the name of the label is. So we do that for the customer, do that for the product. And you can already see how this looks a little bit in text form, just like what the kind of drawing does above it. We take yet another step, of course, and all we're doing is translating that diagram from a graphical representation to a text representation. The next part is to do the relationship, and we do that with hyphens. So if the hyphens are a dash on one side and a dash on the other side, kind of attached to the customer and the product. And we know that the relationship has a direction. So to give the direction, the natural thing to do on your keyboard is use either the greater than or the less than symbol for actually turning that kind of hyphen into an arrow. So now we've got a customer with an arrow going across all the way to the product. Another piece that we need to do here is, of course, that the relationship has a type. We know that it has a rated type in this example. To kind of set it apart from the dashes that we have on either side, we use an angle bracket to kind of add extra information about the relationship. So I'm sorry, not an angle, square brackets in there to do the relationship. And inside of the square brackets, we're going to add in the relationship type so that it looks like this then. So now we've got a customer who rated a product. Fantastic. So that's the pattern that we want to look for using Cipher, or that we want to create, or that we want to do something with. This is the fundamentals of how you do pattern matching inside of Neo4j. Now, it's not enough to just have a description of the pattern. If you then, this is just kind of, hey Neo4j, I'm describing what I want you to go look for. You can then do some extra work with that. Like you want to say, actually, any of the customers you find, could you please put those customers inside of this variable C for any of the relationships that match this pattern? I want that to be a variable R and a variable P for the products. So now any of the patterns that are matched inside of the data set, you'll get a C for all the customers, an R for all the rated, and the P for all the products. Not that no, yeah. So that all makes sense, right? Having established that pattern, we can take that pattern and put it inside of various clauses inside of Cipher. Cipher has a lot of things, a lot of concepts that are in common with SQL. So of course it has read clauses and write clauses and things like that. It even has things like where clauses for qualifying those variables that we just kind of defined. Here, the simplest thing that we can possibly do is say, actually, we know that Neo4j does pattern matching. So there's a match clause. The match clause is go find these patterns, match these things, and then return them as a result. So this is a read query where we're going to read from the database patterns that match customers who rated products. And then for those customers, return their name, return the name of the product, and what the rating was. And we're using some aliases here as well so that the results come back with just customers, products, and ratings in a nice form. Okay, there was a quick run through of Neo4j, the data model, how we think about data, and how we actually represent the queries of Neo4j inside of Cipher. Hope that made sense. Quick refresher for you. Sorry if this was a little redundant for those of you who already know this, but now you've definitely got it in your head, because this is all going to translate very nicely from model to query language into an application for creating dashboards that Niels has created, the fantastic NeoDash with the fantastic Niels de Jong. Please.
Thank you. That's a very nice introduction. I see one question in the chat. I guess we can do it afterwards because it's a kind of a NeoDash question, unless I'm missing something. But
yeah, I thought we can keep the NeoDash questions for the end. There was one comment though. Maybe that's something we can pick up right now. Is Roger said when you mentioned about it, you can have multiple labels on a node, which is it's not a new addition, but it was recently, I think, came up a couple of times that people weren't aware of this. Always thought of labels as nouns, properties as adjectives, and relationship labels as verbs, which is generally a good guideline. But the additional label gives it another level, another spin, so to speak.
Yeah, I think what they're describing there is the exact right place to start when you're doing data modeling. And people tend to start with just very exact labels for their nodes, like the people are called persons. They don't get more complicated than that, I think, initially. And you're right, like it's not obvious to people necessarily right off the bat. Like, why would you have extra labels? And I touched on that a little bit, and I think this ends up becoming an interesting modeling decision when you're looking at any kind of data set, that the natural place to start is that a label is a way to give a type, really, of a thing. That's, I think, what people tend to do, right? So if they would have created a table in relational database world, you're going to give it a label inside of the graph database world. There's usually a one-to-one mapping there. But then the next step is pretty interesting, where even over in relational world, you might have multiple tables for basically the same kinds of things. You might have an employee table and a customer table and a supplier table, things like that, and they're all separate, but they all have actually the same kinds of data. So from a type perspective, those are all just people. Some of those people have extra information, right? So like the suppliers might have, an area that they cover or something like that might be different than customers, but they have a lot more in common than they have separate. So an interesting thing about labels is that you could just have everybody has, or people first, and so that everything in common with people, and then some of those people might have an employee label, some of them might have a customer label, those kinds of refinements to them. Or as I suggested inside of this example with the retail, things like labeling this MacBook as being fragile. There might be other things, sort of cross-cutting sets of relationships. I'm sorry, not relationships, of labels, of groups of nodes that might be appropriate. So once you realize this possibility, it ends up mixing in either kind of refinement in a type setting, type system kind of way, or in like different ways of actually organizing your data. If that makes sense.
Yeah.
I hope that answered the question, or at least gave some insights.
Yeah, I think so. I mean, it's unfortunately sometimes a little bit it depends kind of question or kind of answer, where you have lots of possibilities. The more options you have, the more things you can do in different ways, and it very much depends on what are you working with, what's your data model look like, what's the queries you want to run, what's the outcome that's supposed to be happening here. And then sometimes fragile can be a label, sometimes it can be a property, sometimes it can be something else, and that very much is a bit of a modeling kind of question. If you want to interested in data modeling question in the concepts, the next road to nodes training we are doing on the 27th, so in a week, we'll exactly talk about this. So we will have Glenn join us, talk about graph database, graph data modeling, best practices, tips and tricks, and stuff like that. So I think that's maybe
and Glenn is awesome. He's a great person to have for that. Yeah,
a good follow up kind of thing. Yeah, cool. Yeah, exactly like Vasu also says in chat. Additional label is useful for HR domain. Job seeker can be labeled as hired, experienced. At the same time, sure, you have opportunities there to set it up depending on the individual domain and individual questions you are facing. Cool. I think we are ready to continue, and let me get the slide back up and talk about NeoDash.
Cool, thank you. Right, so quick introduction. I guess Alex already introduced me a little bit. So my name is Niels, based in Holland. You can see it's very sunny here. And what I do in Neo4j is I am working in a professional services team. So what my team does, we help people go from their proof of concept to kind of a full stack Neo4j solution, whether that's data modeling, as we just discussed, API development, or visualization as well. And that's the topic of today. So in Neo4j, we have a lot of different options to visualize the graph. One of the tools, maybe you've seen it in the preview just before this stream, was Bloom. Bloom is an exploration tool where you can do a no-code exploration, click around your graph without writing any queries. NeoDash is a different tool. So this is a tool to build dashboards. You'll be actually writing some Cipher here. and lets you kind of create these interesting dashboards with both graph visualizations and other visualizations in it. So let me see if I can go to the next slide. How do I do that, Alex? Oh, I don't know if that was me. Cool. Right. So I think we had a nice quick intro from Andreas. So we have a little bit of an idea what is a graph. We saw a little bit of the shape of Cipher. And what I really want to do now is get hands-on and explain by means of an example how such a dashboard looks like with some Cipher queries. So first, I want to do a super quick introduction to NeoDash just to set the stage on what this tool is. Again, I cannot skip the slide. There you go. So NeoDash, as I said, it's a dashboard builder for Neo4j. It's an open source tool, which means you can go to GitHub right now, clone it yourself, use it. But we also have a cloud deployment available. It's a low-code tool, which means that all you need to do is write Cipher, and the goal is really to build an interactive Neo4j dashboard in minutes if you're proficient with Cipher. And we will try that later on. As I said, graph visualization, you can imagine the straightforward network of connected nodes and relationships. That's one of the ways you can visualize a graph, but there are many different other ways, right? You can put this on a map. You can have tabular views of your data, projecting the graph into a table, bar charts, line charts, pie charts, and I can name many, many more. And often what people want to do is combine these and then also link them together, creating kind of this unified view of your data. NeoDash is a Neo4j Labs project, which means that it's kind of in the incubator of Neo4j, where we test drive the latest and greatest stuff in our ecosystem. So just a little disclaimer there. A lot of people use this for prototyping, but also for production use cases. So it's quite a cool project, and we have a growing community around this tool. So very, very interesting stuff, I hope. Moving forward. Right, so what does it look like? And I see my GIFs broke today, but it's as I said, a low-code editor, which means that you write queries and they get visualized right away in a dashboard. It's a drag and drop interface, which means you can drag and drop these visualizations together, and you can also link them together by means of parameters, which I will show as well. And again, what I said, the goal is really for anyone, if you have your data in your graph, to create a dashboard in a couple of minutes, which is a nice way to demonstrate what you've been working on after you worked very hard to load your graph. And next one, please. Cool, right. A nice thing about this tool is that it's also fully extendable, which means that you can write your own custom visualizations for it. You can add custom branding. You can add custom coloring to visualizations. If you're savvy with JavaScript, you can even add in your own functionality. So this is kind of an extendable framework that's not just something that's out of the box, but something you can customize as well. We'll be showing some of these nice plugins in the demo as well, including rule-based styling, which includes adding, for example, style rules to your data. So if this node has this value that's greater than 100, make it red or make it big. These kind of things you can do in NeoDash too. Next slide, please. Cool. Right. So zooming through the slides, I think we'll get to the fun part here, which is the hands-on part. I'm going to start sharing my screen now, if that works. And let's see. Okay. Can you see my screen, Alex?
I can see your screen. Yeah.
Awesome.
I'll put it on. Currently, you show the same window. So if I put it on now, we get infinite window arrows. So let's me if you put something else on your screen, then I'll switch it over.
Okay. Wait 1 second. This is always the hard part. Entire screen. Can you see a nice paper?
I can still see our the browser view basically from the streaming tool.
Okay, that's interesting. I'm choosing to share my entire screen. How about this one?
Yeah, now here it is. Yep.
Great. Yeah, you can see the paper? Terrific. Great. Yeah, so let's talk about the data. So what we're doing for this demo, we are working with a nice public data set. And this is one that I recently found. So apart from doing graphs, I really like to cook. I'm not the best chef in the world, but I really like to dabble and then try out different things in my kitchen. So I've been thinking how we can potentially use graphs to help out in the kitchen. And one of the things I had in mind was if I have some stuff in my fridge, I don't want to throw that away. I don't want to waste food. Can I use a graph of ingredients and recipes to recommend me a dish based on the leftovers that are in my fridge? So starting with this idea, I was looking at some data sets and I found this very cool one from which is a really, really interesting million recipes, including its instructions and its ingredients. So this is the data set here from Kaggle. And what you can see here is it's a pretty big CSV file, 2 gigabytes, with a variety of recipes. So for example, here, a recipe here for creamy corn, which includes these ingredients in these quantities. So 2 16-ounce packaged frozen corn. I apologize for people that do not use the imperial system, such as myself. This is what is here. And the directions as an array, a link to where it came from, and then also the actual ingredients without the quantity. So these were extracted using entity recognition. So what we really have here in this data set is a recipe, a list of ingredients, and a list of directions. So what I've done is I've loaded this data set into my Neo4j database, and I turn that into a graph where nodes, the ingredients are nodes, recipes are nodes, and these are connected. You'll see that in just a bit when we look at NeoDash. Just a small note before getting started, and I'll just show this like this, Alex, so you don't have to jump back. So again, the challenge here, looking at a recipe graph with ingredients, steps, and the data sources they came from. And one of the goals that we had in mind was, can we avoid food waste? Can we look up some interesting recipes, put in what's in my fridge, and have the thing recommend some recipes to me? Other things that we're going to try to tackle in this half hour is creating a search engine for recipes. So looking at the graph and then searching for recipes and then recommending recipes with given keywords. We could even take a stab at identifying common combinations of ingredients. So for example, can we learn that honey mustard goes well together? Or can we see that potatoes with butter go well together? So we're going to try to look at that as well. And then last but not least, can we look at existing recipes and come up with our own new recipes as well? So quite a lot to do here. I think it's a really nice data set because the graph itself is quite simple. You'll see that it only has four types of entities, but you're able to extract so much information just by looking at this data set as a graph. Right. And then the final note, what I'm going to be doing here, I'll be using NeoDash. And as I said, you can access that for free on neodash.graphapp.io. And we also will be using Neo4j Aura. And Neo4j Aura is the cloud offering of Neo4j, which is actually also available for free at neo4j.io. And I think that's it. So I'm just going to get my hands dirty here and switch over to NeoDash. Right, let's get this out of the way. Great, perfect. So right now I'm in NeoDash, and what I've done is I've connected to my Neo4j Aura instance. I already preloaded all the data. I took care of all the dirty work, turning that CSV into a nice graph. And after I connected to Neo4j, I'm presented with a nice blank canvas here. So what I'm going to do is I'm going to create some visualizations here. So these blocks, or cards as I like to call them, for each of them you can write a Cipher query, and that Cipher query will visualize the results in a variety of ways. So if I want to see, let's say, some recipes with some, let's see, has step, R, H, S, R, H, S. limit 20. So simple Cipher query here to find some recipes with some steps and showing those on the canvas. I'm doing a limit 20 here because I've actually chosen a pretty big database, and you can imagine a graph with 2.2 million recipes will be a really, really big thing to show on the screen. So we're going to start with a small one here. And I will choose to visualize that as a graph. So what we're seeing here, and then just make that a bit bigger, is based on the query I wrote, I can see a couple of recipes floating in space here. So let me just bring these two close together. Right, so what we have here is two recipes, one called no bake nut cookies and one called chicken funny. And we see that these recipes both have 1, 2, 3, 4, 5, 6 steps. So if I choose to show a tag description on the steps, we can actually see what the step is. And then suddenly we see a lot more information here. So quite a nice way to visualize your data. Obviously, you can also imagine this is as a table. If we visualize the recipe name and the step description inside a table, we get a similar result. And the recipe, of course, has a title and not a name. Great. So same data right here, but now we have it visualized as a simple table, projecting that graph back into a table. And this is a pattern that you'll see me do a couple of times, showing both tables and graphs of the same data side by side. Right, so let's move this out of the way. And what I typically do when I create a dashboard on top of Neo4j, I start with the schema. And the schema is kind of an overview of the different types in the relationship. And how you can get that in Neo4j is by writing call db.schema.visualization. So this is a utility function to display the schema. And what you'll see here is, again, this picture that I showed you earlier, right? Recipes, steps from a given source and with given ingredients. So let's keep this in mind here for when we're writing our query, so we have a nice shortcut to see what this looks like. So I'll leave that out here. I'll move this out of the way, and we'll start doing some more reporting on this database. So maybe it's interesting to actually check if I was saying the truth and see if we actually have 2.2 million recipes in the database. So what I'm going to do here is yet another Cipher query. I'm matching on all recipes and asking Neo4j, please give me the total count of recipes. So if this is correct, it should return 2.2 million recipes. So that looks all right. One thing that I can then also do is, instead of showing this in a table, it doesn't really make much sense. We can do that in a single value report because it's just a number, right? So let's put that up here, and we can add a label, total number of recipes, and I'll call this schema as well. Right, so we have the total number of recipes, and maybe we can also check how many ingredients we then have in the database. So let's try that again, ingredient, and we do a similar thing, right? Getting the total count of nodes with a label ingredient, also as a single value. And then we're starting to see some interesting data here. So we have 2.2 million recipes, but we only have 200,000 ingredients, which maybe seems a bit strange because a recipe obviously had multiple ingredients, otherwise it would be a very boring recipe. But this is actually the number of unique ingredients in the database and not just the number of, how do you say that, ingredient uses in recipes. So this means we actually have 200,000 ingredients that may or may not be shared in different recipes. And I'll show you this also in a bit, what that looks like. But basically, we have some nice interconnectedness, right? Probably we'll have an ingredient that is used in 100 recipes or maybe 1,000 recipes if everybody uses apples and flour to make their apple pie. Another one, 2.2 million recipes, as I said. Let's also see how many steps we have in total in the database. So again, the same pattern. Give me the total number of unique steps used to create these recipes. And let's see. Okay. Let's not return all steps because that's a bit much. Let's start with the count. 10 million steps, right? Okay, that makes sense. So on average, a recipe in our database will have around 5 steps, it seems. Okay, again, let me resize this one a little bit more and make some space and organize my dashboard. Total ingredients. And this was the total steps. Cool, right, so very high level analytics of our database. Just to kind of get a feel for how big our graph is and what's going on. So it's actually quite a sizable graph in here. Let's actually look at some more interesting data. So I'm gonna probably move you here and make you smaller, move you here, and then start looking at some actual recipes that are in this graph. So the first one that I wanted to look at is some recipes for burgers. So we're gonna look at all the recipes and we're going to find all the recipes that have the word burger in them. So another Cipher query that I just created here, find me all the recipes, and this is a where clause, which you might recognize from SQL, which has a very similar thing. And I'm telling it, Neo4j, please give me all the recipes that have the word burger contained in the title. And let's first draw that in a table. Now, I'm also going to be careful here because I know my database is big and I don't want to blow it up. So I'm going to start with 100 recipes first. And we're already seeing some results coming in here. So butterbird burger with garlic confit and many more. So it's a lot of data. Maybe just for fun, let's see how many we can get in total just by looking at burgers. So 10,000 burgers. So we already have 10,000 burger recipes in this graph. So it's a big graph. So let's work on this a little bit and show the graph visualization of the burgers as well. So right now, working still with that same query, I'm showing that in a graph. So what we expect here is we get a bunch of nodes. So one node for every burger. I'm going to do the same as before, and I'm going to make this bigger so we can see that well on the stream. And just zooming in on one of these recipes. So we have our burger here. So let's look at this one, slightly spicy black bean burgers. And if I right click on that one, I can see that this node actually has relationships attached to it. I can see there's 12 steps and 11 ingredients. So let's explore the ingredients for this one. So what you just saw is expanding outwards, looking at my graph, what ingredients are actually used inside this node. So we see these black bean burgers are using this set of ingredients right here. Black beans and nothing super surprising. Frozen corn is something that I personally wouldn't add to a recipe, but that sounds interesting. Actually, we can click on this recipe as well and see some more about the directions as well. So let's see how they're using this corn. I guess they're using the corn to make the patties themselves. Okay, interesting. Right, so we can actually look at some other recipes as well. This one here, Trini burgers, 14 ingredients. And you saw me just expand this node too, created a bunch of new ingredients floating in our visualization here. And we see that these two have one in common. So onions are used in both of these burger recipes, which is nice because now we're already starting to see some patterns in our graph, right? These burger recipes, they are quite different, but they have one ingredient in common, which is onion. And if I fetch another one from floating back there, we see that these two have oil in common. Now, what I can probably do is look a bit further and look at the ingredients as well. So this burger has papaya in it. So let's see what else has papaya in it. Now I'm seeing here 1,000 things have papaya in it. So I need to be a bit careful because if I expand this one, I get a very dense graph here. So we're seeing here thousands of recipes that are using papayas in them. So this is a nice way to explore the graph. But as you can see, with a densely connected graph as we have, it quickly becomes a giant visualizations. Cool. So that's just looking at burgers. So let's do this in a little bit of a nicer way. without clicking around. We had our recipes, and we know that ingredients are in them. So let's visualize the recipe and the list of ingredients. So yet another Cipher pattern that we're seeing here. I'm finding recipes and the ingredients that are in them. Again, remember that we're only looking at burgers. And what I'm actually returning here is the title of the recipe, as well as the list of ingredients. So I'm using a collect statement here, which will turn my individual ingredients into a list. So what does it look like in a table? It looks something like this. So now we have our burgers, some of the ones that you just saw floating around, and then a list of different ingredients, which can get pretty complex as you can see. I'm actually quite interested to see how many steps it could potentially take to create a burger. So let's try to look at the most complicated recipes. So if I order by as ingredients, order by ingredients in descending order, I'm now looking at the burgers that have the top 20 most ingredients in them. So the top 20 most complex burgers to make. And actually, let's just put that in a graph again. So let's go back to the graph and visualize only the top one recipe. Let's look at the most complicated burger here. Let's see. No, that can't be right. That's only 7 ingredients. And maybe I should order by the size of ingredients. So we're actually looking at the length of the list of ingredients and looking at the biggest one there. Okay, that looks more like it. So let's return the relationship as well. And look at that one here. And that's not what we wanted. So let's because I'm only returning the top one. So let's do the top 100. Okay, now this is looking interesting. Now we're starting to see a real nice graph visualization. So remember, the green nodes here are the recipes. Here we have probably a Canadian burger, some other interesting burgers, and we're starting to see a real graph pattern here, right? Some of these that you've seen before, onion is used in 5 of these burgers, but not all of them. So that's one is getting kind of a central place in the graph. And these other ingredients, some of them are kind of on their own all the way at the end of the visualization. Oh, pineapple burger. I don't think that's such a good idea. Anyway, you'll start to see that by analyzing the graph, by analyzing these patterns, we can discover some very interesting insights about common ingredients that would be much harder to see when you're just looking at a table view. Let's get a bit more creative here. So we've seen tables, we've seen graphs. Maybe we can do a nice bar chart as well. So let's look at the average number of ingredients it takes to create a burger. So let's go back to the start. And what I want to see is how many burgers have 3 ingredients, how many burgers have 4 ingredients, how many burgers have 5 ingredients. So I think that's a nice one to show in a bar chart visualization. So back to the drawing board here. Let's get all the ingredients for the burgers and return the size of the list of ingredients as well as the recipe title. Let's start with this one. So let's just see if we can get a number there. Okay, right. So this burger has 7 ingredients. Okay. And let's go one step further. So if we get the size of ingredients and the count of the total number, No, that's not what we wanted. Okay, so this is my punishment for doing live coding here. So let me try this out. Title, ingredients, and return ingredients, count r.title, limit 5, count title. Okay, yeah, that's looking good. Right, and then finally, and I will explain this in a bit, order by count, ascending order. Okay, right. So next step in our Cipher journey. So you'll see I'm starting to get more and more complex in my Cipher queries as I'm exploring further the graph, trying to get more interesting results from here. So what am I doing here? I'm finding all the ingredients in burgers. Then I am collecting for each recipe by its title how many ingredients are in there. And I'm actually chaining this together with yet another aggregation at the end, where I get the total number of ingredients and the number of times it occurred. So this will give me 7 ingredients occurred 100 times, 8 ingredients occurred 200 times. And by using this with statement here, this is a nice way to kind of pipe results in your Cipher query and chain them together. Able to accomplish this kind of double aggregation, both counting the number of ingredients and then again also counting how often that number appears in total in the database. So final result is not what I wanted. Let's see, count 1. Interesting. Let's see, what am I doing wrong here? I think it might be this. Nope. Let's see, title. So this we did all right, but now we want to see right, this works. Then why doesn't it work without the limit? Oh, okay. I guess I was messing something up. Order by ingredients ascending. Fantastic. Okay, cool. We're back in the game. So ingredients and how often they occurred. Now bar chart, and let's see what it looks like. Okay, nice. It looks almost like a normal distribution, or maybe an exponential distribution actually. So what are we looking at here? We're looking at the average number, the number of recipes that it takes to make it with a given amount of ingredients for a burger. So we have in total 719 recipes that have 10 steps. We have almost 700 recipes that take 9 steps. And it seems like we even have one recipe that takes 1,000 steps. Now that doesn't seem correct to me. And I think I know why that is. So let's fix that here. And oh, that's still not correct. That is strange. A recipe with 1,100 ingredients. That is too complex for a burger. Title. There we go. That makes more sense. So the problem here in this database is that we have multiple recipes. This is something that I wanted to show you as well in a couple of visualizations. So we might have 10 recipes called blueberry pancakes. And what my query was doing here, it was actually adding up all these ingredients from all these different blueberry pancakes into one recipe. So probably we had 15 recipes called cheeseburger and adding that into one account. So we still have some complicated recipes here with 200 steps, but no more 1,000 step recipes. Cool. Right. So moving forward, so this was kind of the high level, doing a kind of a analysis of what our data looks like. Let's actually try to solve some of the problems that we started with at the start. So I'm going to make a new page in my dashboard. I will call this recipes, and oops, recipes, save. And now I'm going to look at some specific recipes. So let's look at some pancakes recipes. So give me all the recipes where the title is pear pancakes, and give me that node, please. So let's look at all the nodes that have a recipe label and a title pear pancakes. Okay, it's only one. Now let's actually show the ingredients as well. So we're extending the Cipher query and also returning the ingredient. And let's put that on the screen too. Great, so we have our pancake recipe on the left here. Pear pancakes contains pears and something to make the batter. So that makes sense, and maple syrup. One of the things that I haven't showed you yet is interactivity in dashboard. So what NeoDash can do, it can let you as a user dynamically specify part of this query. So what I'm going to do is I'm going to create a new visualization of the type parameter select. And what this card here lets users do is select a specific property from a node in the graph. So let's try that out with our recipe. So if I let my user choose a recipe title, I will get a selector here. And if a user starts typing, they should be able to see some recipes for pear pancakes. So with a very simple visualization, with a very simple query or component, I've created this kind of interactive box where users can specify a specific substring of a title. In a way, it's kind of like a search engine, right? So looking at all the things that contain the word pear pancake. What we want to do is actually use this value in the graph visualization as well. So this thing has just produced a parameter, NeoDash underscore recipe underscore title. And that parameter I'm plugging into my Cipher query on the left here. So if I save this now and I go back here, you'll see that this visualization is no longer working because it's waiting for that parameter. So let's try apple pancakes. And let's start pineapple pancakes. So you'll see here that the value that I've just chosen here was added dynamically into the visualization on the left. And we didn't just find one recipe for pineapple pancakes, we actually found 3 that are also connected to each other because they share flour and sugar and milk and eggs. What's actually most interesting is that only 2 of the recipes use pineapple. Oh no, this one uses pineapple, crushed pineapple. I guess that's not the same. But yeah, this is a very nice way to dynamically let the user of the dashboard specify some parts of a query. So maybe what other pancakes can we have? Let's do strawberry pancakes. Right. Okay, that is even more interesting, right? We have 7 different recipes for strawberry pancakes. Now let's combine this graph with a table next to it as well. So we'll take the exact same query, but now we will do the same that we did earlier, where we visualize the title of the recipe plus the name of the ingredients. And I'll save this. And actually, let's see here. And why aren't you working? And also the ID of the pancakes, of the recipe. Cool. Right, so let's make that bigger and I'll move you to the top. And now we have a search engine for looking through a graph that visualizes the results both in a graph view and in a table view. And this is all dynamically linked through NeoDash. So you'll see here that NeoDash takes the parameter name from here, and the moment I choose something else, we'll see the visualizations update dynamically. I can even do that in the title here. I can say recipe for NeoDash, recipe title, and it will plug in the word Dutch pancakes just because we've selected it up there. So I've just created a nice, very simple search engine right here. And then the user, of course, they can look here and they can click around, and maybe they can even go further and look at all the other recipes that also contain arrowroot or whipping cream or freshly ground white pepper or green apples. And when they click on a relationship or a node, they can also inspect the properties of it. So for ingredients, actually one thing that we don't have yet is the steps. So maybe we can get that as well. So let's get another block right here and visualize the steps. Now we had a relationship called hasStep and sStep. And I want to return set of step descriptions. Very similar query, but now I'm actually looking at the step nodes that are attached to the recipe and visualize that one. Great. Now that is actually too big to read. So one of the things that I haven't showed you yet is customizing the visualizations. In this case, the single value report is the font is too big to fit inside this chart here. So one of the things that I can do, I can customize this visualization. I can change the background color. I can change the text color, but in this case, I just want to change the font size. And maybe I'll make the color green as well. So you can also get more advanced in your visualizations and customize them like this. That's still too big. And try this one too. And let's see. Okay. I've actually made the same mistake again because I've chosen a multiple recipes. This view contains all the different recipes chained together. So I only want to see one recipe in there. So maybe we can go back to our pancakes. And now we have our things nice and clean in there, although it's still quite long. Anywho, final thing that we haven't really touched yet is the data source. So the pear pancakes come from a recipe website. So if I look at the node attached to here, I see it's actually attached to a source node. And the source node has a URL on it, which is this website, food.com/recipe. Maybe it would be nice to show this website as well in the dashboard. So let's see if I can, let's see if the website's still online. Yes, it's still there. Good. So how can we do this? So let's think a little bit. We want to have a user see this specific website inside their dashboard. So what we can do in NeoDash is, let's copy the link, create an iframe report as well. So we will be able to visualize different websites in the view. So if this works, and sometimes it doesn't like it. And I think it's because I'm not using HTTPS. There you go. Now we've got our pear pancakes nicely in the dashboard as well. Now, what you saw me do is adding this link directly, but maybe it would be nice to do it dynamically and have the user choose the recipe based on what's in the visualization here. So let's try that out. Let's change the query and not only visualize the recipes and the ingredients, but also visualize the source nodes. Clicked. And we'll go back. Okay. So also visualize the source nodes. So I'll extend this query to show me not only the recipes and ingredients, but also the source where the ingredient comes from. And when I run that, you'll see the visualization has changed. And now we have this nice green node here as well. And what I want to do is when I node, I want to show the specific iframe down there. So how I'm going to do that is via a plugin. So NeoDash, as I said before, there's a lot of interesting options for plugging in new functionality into the tool. And one of these tools is called Report Action. So this is a plugin that creates even more interactivity into the dashboard rather than the selectors that I showed you earlier. So by turning this on, I can define a click for that specific node. So what I want to do is I want to create an event that says if a user clicks on my green node here, set a parameter that I can then use in my iframe. So let's try that out. So as I said, this extension that I just turned on created a new button here, set report actions. I can click there, click on the plus, and I can do exactly what I just described. So I say if the user clicks on the source, set my parameter source URL to the URL of the source. Again, if the user clicks on the node, set this parameter to the URL property of that node. So what does it mean? That now in my iframe, I can use NeoDash source URL and save this. And let's see. This is my HTTP again. So let's actually. So this is a browser thing where browsers don't allow you to embed HTTP in HTTPS websites. So what I should really do is, this is going to be quite painful, update some recipes here to not have HTTPS in them. Let's think for 1 second how we can tackle this. Maybe there are recipes in this data set that are on HTTPS. Otherwise, we'll just forget it. Ham. Let's try some ham. No, these are all HTTP based. Okay, well, that's unfortunate. Essentially, what I was trying to do is clicking on a node and then setting that parameter dynamically. But unfortunately, my browser doesn't allow it because it's HTTPS. Anyway, you'll see here, there are many things you can build. Freestyling here, trying out different things. But you can get pretty creative with these dashboards, combining iframes and bar charts and all kinds of visualizations together inside your dashboard. Let's try the final thing that I want to show you here, which is kind of the original problem that started this idea of creating this data set, creating this graph and looking at it. And that was, can I enter into this system the ingredients that are in my fridge? And can you please recommend me a recipe with these ingredients that I have left over? So we're gonna create a third page on this dashboard called ingredients, and we're gonna save that. And again, we're gonna create a report. So we just did a search for recipes. Maybe we can create a search for ingredients as well. Parameter select. I let my users choose a node property from nodes with label ingredients and property name. So if I start typing now, I can see ingredients that contain the word apple or apples. Funny thing about this data set is that they did some natural entity recognition. Unfortunately, not all entities were correctly parsed. So you'll see some interesting stuff here. You'll see apples with a some trailing characters in there. So we'll need to do a bit of cleaning on this data set. But it works. It works. It's good enough for most of our purposes. Let's try it. Let's try pineapple maybe. Yeah, you'll see pineapples. So there's some cleaning to be done. But anyway, the search is working. And now let's do the same thing that we did before, but the other way around. So give me the recipes that have an ingredient. in ingredient. But now instead of matching on the recipe title, we do this the other way around and we match on the ingredient name equals NeoDash ingredient name return R in I. And let's do not too many, let's do 50. 50 recipes with pineapples in them. So now we have built the opposite search engine as I did earlier. Rather than looking for recipes, we're looking for ingredients. So that's already quite nice. Not really what we wanted though, because I can only choose one ingredient. And what I really want is to put all the stuff that's in my fridge and recommend an ingredient with it that a recipe with it that has all of these ingredients in it. So let's see if we can work our way there. Maybe one thing that's also interesting to try out is to look at common pairings of ingredients. So you remember earlier I said honey mustard, is that an interesting pairing? So how can we do this? We can look at different recipes and we can see how often honey and mustard are used together in a recipe. So let's try that out. Let's write another query. So we'll start from the start. Let me just steal this one because I don't have to type it again. So what do we want to do? We want to find ingredients that go well together. Actually, let's start from here. So what does it mean? Ingredient pairs. These ingredients are used in recipes together. Therefore, in the graph, the recipe nodes must have other ingredients to them. So in this case, as an example, let's see. Come on, get out of here. We have honey, which is used in chicken dippers with honey mustard sauce. And we have paprika. So honey and paprika are a pair because they're used in honey mustard in this recipe together. Now let's see if we can identify common pairings because there could be thousands of recipes that are in together. So we're going to write a query that calculates how often things are used together. Let's try it out. Again, starting from our ingredient used in a recipe, and that same recipe must have another ingredient, which I will call, let's make that larger, I2, ingredient. And now let's try returning I.name, I2.name, and the total number of recipes in which they are used together as count. Okay, let's break this down. As I said, an ingredient is used in a recipe. That same recipe has another ingredient used in it as well. So we're looking at a graph pattern here, 2 ingredients in the same recipe. And what am I doing? I'm filtering again based on my parameter here. So only looking at honey, pairings with honey. And I want to see honey, the other ingredient name, and the total number of usages. So let's visualize this one. And this one will be a bit complicated because it is looking at a really big part of the graph here. Right, so these are the results. Honey is used with baking soda 4,000 times. Actually realizing here that we should probably order these and order by, count, sending order. Great, right. So this is what we wanted. Honey is often used together with salt 29,000 times. Not sure if that's very meaningful, but it is a finding, right? It's maybe what we expected. Garlic. I don't see any mustard here. Maybe if I go down, here, honey mustard, 5,400 times. So it's quite a lot. It's quite a lot. So what you actually see here, this is a recommendation in a way. This is a recommendation of things to use together with honey. It's a very rudimentary recommendation engine that we've written in what is it, 5 lines of Cipher, which is quite cool. Some of these don't make much sense. Honey and water, for example. but we might see some actually interesting combinations of food here. Great. Interesting. But now let's go to the final challenge. We will, you know what? Let's make another tab for that and call that fridge recommender. Okay, let's go back. Ingredients, selector, ingredient, name, and right, we're back at the start. Choose your ingredients. What I said last time, I want to enter different things that are in my fridge, not just honey. I want to select everything that's on my shelf here that I want to get rid of. So what I can do in NeoDash, I can go again to my advanced settings and go into this customizations, and I will turn on multiple selection. So what multiple selections let me do is choose multiple values in the same selection box here. So now I can actually choose two things, honey and mustard. So this is now an array of values that I can use for my filtering. Now, we're going to have to write a bit of a creative Cipher query here to work with this new type of parameter. So remember, earlier on, we were just doing find me all ingredients. Ingredient where I.name equals NeoDash ingredient name. Ingredient name. Right now, NeoDash ingredient name is not just a single value, it's actually an array of numbers. So what we want to do, and you can see that actually by just returning the value itself, you see this is two numbers right now. So what we want to do is we want to bring this array into individual values again. So how we do that in Neo4j with Cipher is an unwind. So we use an unwind statement to turn an array back into individual values. So what I've just done is I wound down an array into a list of single values, honey and mustard. Now with these single values, I can write my query again. And what I will do is I will use another complex concept. We're really going to go advanced today and use a subquery. So in Neo4j, we have subquery support as of, I think, a year or two ago, and we can do some more exotic things. So looking at this list of ingredients, I want to find, again, the same pattern that we've done a million times. Ingredient in recipe where I.name equals, which is now called ingredient, return I in R, limit, let's do 20. Return I in R. Okay, so I'm actually going more advanced than I was hoping to, but nice to go a little bit more deep into what you can do and really explore the power of Cipher here. What I'm doing here is I'm actually, for each ingredient, I'm finding now the recipe. So for both my honey and my mustard, I'm finding the graph that contains them. And then the subquery at the end will return that and put that together into one view. So in practice, what does that mean? Let's take a look. Perfect. So right now I have honey here, mustard here, and I have the two subgraphs of these two ingredients. I'm already seeing there is one overlapping recipe here called mustard onion sandwich buns. So I'm already finding a common ground between the two recipes. And if I select more stuff, let's choose something else. What else is here? Let's say I have some potatoes. Maybe I can find some more things here. So, okay, it doesn't look like we have some common ground with potatoes, but then again, we're also not looking at everything. Cool. Right. So we're getting there. I think we're starting to find subgraphs that contain all these ingredients. Let's get rid of the potatoes, and let's get a little bit more advanced here, right? Um, mm, 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 mm. So one of the problems here, and I think that was already shown by my potatoes earlier, is that we are not just looking at recipes that have all the ingredients. We're actually here looking at recipes that have any of the ingredients. So I'm returning things like vegetable soup, even though vegetable soup doesn't have honey or mustard in it. So it's not an intersection of the different recipes, it's a union of the different recipes. Show me everything that has one of these three. Whereas what I really wanted was show me recipes that have all of these three things. Um, so we'll have to get a bit further into our query. So we're just gonna keep going here. Let's get rid of view limit. And now we'll have to do some thinking. As I said, we want to see only recipes that have every single ingredient in my list in their ingredient list. So we'll have to do some thinking. And how we can do that. One way to do that is to actually ensure that each of these subqueries, the recipe in each of these subqueries is common in the set of all the recipes. So let's just write something, right? This is an idea. So what I'm going to do now, I'm going to find every single recipe that was returned here. Each one of these queries will return a list of recipes. But what I want to see is the total number of recipes. How do I say this? I want to see the recipes that were returned by all the subqueries. So how I'm going to do that, I'm going to ensure that every single subquery returns the same recipe. So let's look at what this looks like here quickly. Maybe that will help. So, yeah, that's it. That's what I wanted to try. r.title. Cool, right. Now we see the recipes on the left here. And on the right, we see the number of ingredients from my list that were contained in this recipe. So you'll see here, many of these recipes have only one ingredient. If I go a bit further, we see, well, honey baked mustard chicken, which returns count 2, because this one actually contained 2 of the ingredients. So I've just managed to get how well matched this recipe was. This one contained 2 out of 3, apparently. What I really want to see, I want to see only count is 3, where every single ingredient is contained in it. So keeping up with my query here, I want to say where the count is 3. Return me the recipe title and the count. Okay, now I have recipes that contain every single one of these 3 ingredients. By just chaining these queries together and actually ensuring that they're contained in all of them, I've actually brought down the result set to only 65 recipes here. So we've kind of accomplished what we wanted, right? We're now able to see only the recipes that have the ingredients that I've chosen here. So let's do this a bit smarter and get the count dynamically. So by looking at the size of the parameter, I first hard-coded that as the number 3, but I can also say, get me the size of this list dynamically here and show me, basically plug that number 3 in here because this thing will return 3. Okay, and it should get the same result. Yes. Okay, fantastic. And then finally, now we have our recipes that have all 3 ingredients. And from those recipes, we want to, again, visualize the results. I ingredients, return R in I. Fantastic. And graph visualization. And I made a mistake here because the ingredient is in the recipe and not the other way around. Boom. And that is actually a lot of stuff. So let's do not too many here. Let's do 50. Okay. Great. So actually, let's let me just one more thing. With our limit 20. So let's only look at 20 recipes at most, so we don't create too much. Maybe 10. Okay. Finally, here we are. Zooming in. Honey, mustard, and somewhere here should be potato. Potato is here. So 3 ingredients that are common in all of these recipes. One of them is for fries. One of them is for salad with tuna. And you'll see here if I start drilling this down even more, like adding more ingredients, we should get a smaller and smaller set of recipes. So let's do mayonnaise as well. Right, okay. So drilling this down into a set of only 5 ingredients, we're down to a very, very small set of recipes. So these are the 2 recipes in the graph that I can make with my 5 ingredients in my fridge. Now this is quite complex. So I can imagine if you're new to Neo4j, this is a bit daunting. But if you think about it, the kind of processing that we're doing here in let's say 12 lines of Cipher or 5 lines of Cipher is actually quite powerful, right? We're doing all these complex pattern matching queries and really using the power of Cipher to express express these kind of complex questions and solve these problems that again would be very hard to solve without a graph. And visualizing that as well in a really nice way and solving our original problem here. So to give you a taste of kind of more advanced Cipher, I think that was the purpose of this page here. Moving from the start, where we did some basic analytics, simple pattern matching, using parameters, visualizing different things, having some filtering, and eventually going to a complex visualization with a complex matching condition, really exploiting the power of graph and the power of Cipher here. Cool, I think that was it. I will switch back to my slide and maybe answer some questions. So just to wrap up, I hope you enjoyed this. I really wanted to go kind of from basic Cipher to more advanced Cipher and show you all these kind of visualizations that you can build. This data set, as I kind of mentioned, is a work in progress. We're working on this one, creating this, building this out, cleaning it up, and we will be presenting this again at Nodes in October 22nd, sorry, October 26th. I will also publish the data set so you can play with this yourself. It's an open data set. And on the 26th, we will be diving even deeper into the complex Cipher, and we will even use some LLM-powered Cipher queries. So we have some tools out there to transfer natural language into Cipher, which is quite interesting. If you want to try out NeoDash in the meantime, I can highly recommend this site here, neodash-gallery.graphhub.io. And these give you some kind of pre-built, preloaded dashboards on public data. Also with some more simple queries if you're new to Neo4j and get you going. So this gives you a nice playground to experiment with some Cipher, try out different visualizations. One of these is the movies graph that is quite nice to work with and shows you how to, again, write simple Cipher queries and build some nice visualizations on them. Cool, I think that's it. I will stop sharing and maybe there's some questions in the chat.
Yep. let's do this. Cool. Thank you very much, Niels. This was great. We got good insights, good overview, good advanced querying as well in. So I think that was really cool. Lots of praise for you from the audience. So that was definitely resonating with the audience. We have a couple of questions, so maybe we can do a couple of those. A couple almost seems like um, a couple of requests to the queries. Sebastian and Roger suggested that you could brute force replacement of the HTTP with HTTPS, and even that comes with a Cipher query. But how to do that? I guess that's something you would do on the database side and not in NeoDash. I mean,
Yeah,
on Neo4j. Yeah.
yeah, exactly. But thanks, I completely missed that. That would have been nice if I saw that earlier.
Yeah.
Yeah, yeah.
And then something like almost like a user UX kind of idea is like add another parameter box and have the query depend on both parameters. I guess you have kind of showed that somehow with the one parameter box.
Mhm.
And what was the other thing? Let's see. Yeah, Sebastian suggested or asks if you ever thought about auto-completing while writing Cipher queries. Seems like you have to remember lots of things unknown, all these labels and the names. Is that something you are thinking about?
Yeah, actually, yeah, that's actually quite interesting because other Neo4j tools like the Neo4j browser, for example,
Yeah.
it does a quite a good job at it. So we're planning to kind of take that from the browser and bring that into NeoDash as well. Because you're right, it's sometimes difficult to remember the names of properties or nodes. So definitely something we can improve on. It is on our mind. We're looking into it.
Yeah. Cool.
Yep.
And then a couple other questions. On styling from Osman, is it possible to dynamically adjust the diameter of the node in a graph? For example, if we had a graph of cities, each city node would be sized according to the population of the city. Is that something that can be done?
Yeah, that's actually possible as well. It's one thing that I didn't get around to showing, but we have a another plugin called rule-based styling, and that one lets you dynamically size nodes and relationships or add colors to them. We can add dynamic radius of the nodes based on properties. We can also do relationships. We can make them bigger based on specific values. For example, there's a faster train connection between Berlin and Munich. We can make a thicker relationship. So that's all possible in NeoDash. Maybe I can link the documentation for those interested.
Yeah.
And let me put that in the chat. Okay.
Where did you?
Yeah, I put it in the regular chat.
In the regular chat. Okay, perfect. Great. Yes, super. Okay. This will also be in the video description for later on. So that's that. Let me add that here as well to the video. But it's all in the on the lab. The Neo4j Labs page has the user guide and everything else, and some kind of tutorial also how to get going. There, we didn't talk about this now on how to deploy, I guess, or how to get NeoDash working on. So you showed it on Aura. It's working on Neo4j desktop. There were questions on other deployments like on Docker or something like that. Is there? I think it's all in the documentation. Is it?
Yeah, it's quite maybe right now to not the time to go super deep, but there's documentation on deploying. We have a Docker image that we publish at Docker Hub. You can make this work with SSO as well, so you can hook it up into your enterprise SSO.
Yeah.
If you get stuck, feel free to reach out on GitHub or community forums, create an issue, and we're happy to help out.
Cool. While you say SSO and stuff like that, there was another question on sharing the dashboards with other users as view only. Is that something that can be done?
Yeah, it's possible. It's not as easy as I'd like it to be. Something that we're also improving. But there again, this is in the documentation. You can set up a specific view only deployment of NeoDash and then share dashboards in between them. Something that we're also going to be working on in the near future.
Cool.
Yeah.
And then another question was on the when you showed the schema, the CallDB schema visualization part, that Neo4j feature basically. Can we get that code again? And can we say, or can you say how this? Is it easy to explain in a couple of words how this schema, how the how this procedure basically works and how it knows what to do upon showing that that visualization of the schema bit?
Yeah. I can put the procedure in the chats. This one. And I think the question on how it works, so it's actually inferred from the data. So it's not something that you define up front. Neo4j is schema flexible, which means that we don't have a concept of a strict schema as a relational database would have.
Yeah.
We can somehow constrain it, but in a way it's flexible. So this visualization specifically is inferred from the data.
Perfect. Cool. All right. Some people asked for the data set, but that will be ready when your presentation is taking place later in October. So I think that's something we can have a look at then. Yeah, this was answered more or less. Talked about this multiple parameters. Yes, that works. Automatically updating the graph. Oh yeah, one more question was about these parameters. Are they valid across multiple dashboards within one view per tab only, across tabs? How do they work?
Yeah, so they are global. So one thing that you can do is set a parameter in one page and then jump to another page and use the same parameter. So we also have the report action that I showed you. If you jump, you can create an interactivity action that says set this parameter and immediately jump to another page. So a drill down page, which means you can express that behavior. Yeah.
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 Yeah. Okay. And here was one more. How to make conversation of properties of nodes in relation into visual clues like node size, shape, color, arrow thickness, like in a Viz network software. I'm not sure I understand that question. Conversation of properties of nodes in relation into visual clues.
Alex, I think that might be trying to get at the kind of visual styling rules, for instance, like the way that Bloom thinks about these things, like, oh, okay, if this value is a number, can we use that number for changing the size of the node? I think that's the direction of the question.
Mm-hmm. Yeah, again, it's quite basic what we can do. Bloom is much more advanced in terms of styling capabilities. Right now, it's just mapping it to a range. So you can say the size is 10, or it's a number equal to a property. So you'll need to say width 10 on your node. We don't have the freedom to, let's say, apply styling in a way that Bloom does. Basic styling customization. That's what we can do. Yeah.
Okay, cool. Yeah, and so just to clarify, Roger, yes, you can post your own Neo dashboards on our website and make it available. It's a bit more, like you said, Niels, a little bit more complicated than it used to be. That it should be maybe, but it's a feature that is being worked on. So in the future release, this will be a little bit easier. At the moment, a bit more complicated. But yes, it's totally possible to make NeoDash your personal data using NeoDash available on a website or integrated somehow somewhere for a viewer only type of scenario.
Yep.
Cool. And yes, the session will be available afterwards for replay, so you can check it out. Yeah, I don't think I see any more. Oh, there's one more here. What do we have? Oops.
exporting. Yeah, so I see one about exporting visualizations.
Yeah.
You can export every visualization as a PNG. So that's possible. You can turn it on in advanced settings. So then you can share that locally if you'd like.
Okay. Yeah.
Yeah.
And then maybe, oh yeah, here's another interesting one maybe for from Sarah on user behavior. So can you limit what certain users can be doing? So like saying, okay, you can only search for burgers or can search for pancakes or on the data set.
Yeah.
Is there a way?
Well, I've been talking about burgers too much.
Yeah.
Well, it's
We got
complicated.
hungry very much when you
Yeah.
did that.
So I mean, you can in Neo4j we have a concept of role-based access control. So on the database side, you can control who can see what. So NeoDash is just a client, right? So we delegate that responsibility to the database. I maybe in one of the following sessions, probably at Notes, there will be people that go more in depth on the role-based access control. So answer is yes, it's possible, but it's not on the NeoDash side. It's on the Neo4j side.
Yep.
Yeah.
And one more question from Jeff. What type of view did you use to show the cooking instructions, like this text window? Does it wrap the text automatically?
So this was I don't remember. I think that was a single value view. So there again, there are multiple ways to do this. You can use a single value view, which then wraps array elements automatically with new lines. We can use a table. There's also a markdown view that lets you express more complex text blocks. In this case, it was a single value, although there was a bit of a hack. I probably recommend using a markdown view for that one.
Yeah. Okay.
Yeah.
Cool. Yeah, I think that brings us to the end of the session. Thank you very much, Andreas and Niels for presenting, and especially Niels, obviously, for the demo for live coding. It's always a little bit of a scary feat, but definitely worked very well, and was going super nice. I think that was great. Like we said, if you want to try it out yourself, it's free. So you don't even need to install anything. If you want to go the Aura path, just spin up an Aura free instance, add NeoDash to that, and then try it out for yourself. Play around with some data, either with some data you have lying around, or grab a data set that we provide or that you find on the internet, and go with that, and see for yourself what you can do, what you want to. And if you have any questions, any feedback, specifically on NeoDash, go to the GitHub repo on Neo4j in general. Obviously, reach out to us in the community or Discord channels, and let us know. We'll be back. At least I'll be back next Wednesday for the graph data modeling session. So if you're interested in that, knowing a little bit more about how to do that, and some best practices from Glenn, then join us there. The links to all the Road to Nodes trainings, let me post that in chat one more time, so you don't miss any of those upcoming sessions. And yeah, I think with that, yeah, register for Nodes if you haven't so far. So that's definitely the big one taking place on the 26th of October. And yeah, feedback.neo4j.com. Yes, Andreas, do you want to say a few words about that?
No, I just thought it was another place to know about if you want to provide feedback for Neo4j. And what's nice, I guess, about that area is that you can also load up if other people have some comments or some feature requests. You can +1 them, and that really helps us know like what people are interested in. So, in addition to the community and to the Discord channel, it's a good option.
Totally. Yeah, good point. All right. Yeah, we will share the video and the deck with you all later when available. And yeah, have a good time. See you around, and yeah, until next time. Thank you very much, and take care. Bye.